All right, so in class we talked about the law of sines, and one thing you need to know about the law of sines, it is applicable for any triangle. So now you don't only have to use sine, cosine, and tangent on right triangles, you can use it for any triangle. One thing to remember, if you have some triangle, any old triangle, you have angle ABC. Remember, angles are always designated by capital letters. Across from angle A would always be side A. Across from angle B would always be side B, and across from angle C would always be side C. And if you remember, the law of sines says that the sine of angle A is going over side A is going to equal the sine of angle B all over side B, which will also equal the sine of angle C over side C. Now, you can write the ratio this way, but the ratios will work in the reverse order as well if you prefer. It doesn't really matter which way you do it, as long as you are consistent throughout your whole ratio. So either one of these will work. I usually use the top one, but again, personal preference. So now let's just take a look at an example. Let's just make up some values. Let's just say this is 50 degrees, and we'll say side A is 12, and side angle B we'll say is, I don't know, 20 degrees. Doesn't really matter. All right, and we want to find out everything about the triangle. So of course we can easily find C by just adding these two up. That's 70 degrees. 180 minus 70 would be 110 degrees. Obviously this triangle is not drawn to scale. And so now if I wanted to find side C and side B, I can use this ratio. So I can say the sine of 50 degrees all over side A, which we said was 12, equals the sine of 20 degrees all over side B. So now I have a ratio where I only have one variable. So I can cross multiply and say 12 times the sine of 20 equals B times the sine of 50. And if I want to solve for B, I'm going to divide both sides by the sine of 50. Oops. And now I have B alone. And now I can just go to my calculator and just put that in. So let's see if you can see this. I'm going to say, I want parentheses, 12 times the sine of 20 divided by the sine of 50. And I have 5.36. So I know B is 5.36. Right now that I know B up here is 5.36, I can really do the same exact thing now in order to find side C. And now that I know that this is 5.36, I can use this number here, or I can go back to the given numbers. I tend to want to use the values that are given just in case I made a mathematical error on this one. Then I would make a mathematical error when I continued, because if I have something wrong to start with, it's going to continue wrong. So therefore, I'm just going to use these two in order to continue this ratio. So I'm going to say the sine of 50 all over 12 equals the sine of 110 all over C. Once again, I'm going to cross multiply. 12 times the sine of 110 equals C times the sine of 50. I'm going to divide both sides by the sine of 50. These will cancel out, and I'll have my value of C. So I can go, let's see if you can see this. Here we go. Push this over maybe. There we go. So you've got 12, oh, forgot parentheses again. 12 times the sine of 110, and remember your calculator should be in degrees, divided by the sine of 50, and I get 14.72. So I know now everything there is to know about this triangle. I know all the angles and all the side lengths. So that's how you use your law of sines.